biggest question is whether the reflection of sunlight is coming from a solid surface or maybe a dense cloud of dust.
The laws of physics are not suggestions, they are the guardrails of the universe. But apparently no one passed that memo to 3IATLAS. This interstellar object is cutting through our solar system, and it just did something that left even seasoned scientists short of breath. It fired a jet of material straight toward the sun. Imagine a boat turning directly into a hurricane, sails full, and somehow not slowing down. That's the kind of upside-down physics we're looking at. And as Harvard astrophysicist Avi Loeb points out,
and now, as it approached closer to the sun, there seemed to be some teardrop shape.
This is only one of a dozen red flags. The part most people miss is that 3IATLAS's secrets go far deeper than a backward tail. This is the feeling of the ground moving under your feet. August 2nd, 2025. At the TD Observatory in Spain, astronomers aimed the 2-meter twin telescope at a faint, fast-moving speck against a star-packed backdrop. The target, designated 3I/ATLAS, the third known interstellar visitor, was finally bright enough to probe. They stacked 159 exposures, teased a signal out of the noise, and a ghostly silhouette took shape. Extending from the object was a delicate, needle-thin plume, an apparent jet, stretching a projected 3,700 meters. The problem wasn't the length, it was the direction. The plume pointed directly at the sun. To see why that's a bombshell, rewind to Comets 101. A comet is a dirty snowball, ice laced with dust and rock. As sunlight intensifies, the surface ices don't melt, they sublimate, jumping straight from solid to gas. The expanding gas drags dust with it, inflating a glowing shroud called the coma and sweeping out a tail. And that tail has one hard rule. It points away from the sun. Solar photons and the solar wind act like a cosmic leaf blower, pushing dust and gas downwind. It doesn't matter where the comet is headed in its orbit. The pressure from sunlight and charged particles constantly herds the debris anti-solar. It's one of the simplest, most reliable patterns in planetary physics, which is why what 3I/ATLAS shows is so jarring. In the rush to label it just another comet, many overlooked that this jet, this apparent anti-tail, was doing the opposite. It wasn't surrendering to the solar gale, it was pointed into it. Avi Loeb framed it with a striking image. It's like seeing a photo of an animal everyone insists is a cat, except the tail sprouts from its forehead. You don't need a PhD to know something doesn't add up. If this sunward jet were built from the same dust grains that make ordinary comet tails shine, the grains about the size of visible light wavelengths, solar radiation should shove them away with ease. Those particles are excellent at scattering sunlight, which is why comets are visible at all. But the very property that makes them bright also makes them pushovers for the sun's pressure. They should be swept anti-solar, not sharpened into a lance aimed at the light. Yet the images show a tight, directed plume, not a smear, not a processing artifact, a feature with intent. And this wasn't a one-off glitch. Weeks earlier, the Hubble Space Telescope recorded a similar sunward glow. The Spanish 2-meter confirmation made it unavoidable. The feature persists. 3I/ATLAS keeps showing us a plume where a plume should not be. That raises two immediate, uncomfortable questions. First, what is this jet made of if ordinary dust can't hold that formation against solar pressure? Something denser? Something that doesn't scatter light in the usual way? Something active, not passive? Second, why are so many voices eager to wave away a glaring contradiction and fold 3I/ATLAS back into the standard comet file? You don't fix a forehead tail by squinting. But the jet is only the opening note. It's the smoking gun that leads you into a larger crime scene. Because the moment researchers started combing through the rest of the evidence, the tidy comet story began to fray. Loeb and others stitched together a list of anomalies, and the composite picture looked like nothing we've cataloged before. Start with scale and momentum. Based on its brightness and behavior, 3I/ATLAS appears massive. Monstrous by interstellar visitor standards. The estimates place it roughly 1 million times more massive than our first interstellar interloper, Oumuamua, and about 1,000 times more massive than the second 2I/Borisov. That is not an incremental step, that is a cliff. Now consider the implication. A body that large should be conservative, predictable, reluctant to budge under anything but gravity. Outgassing on a typical comet can produce a tiny rocket effect, what scientists call non-gravitational acceleration. But if you truly have a sustained sunward jet on an object with this much mass, the books demand to see it in the trajectory, either a measurable deceleration toward the sun or a persistent, coherent course correction that matches the thrust vector. Show the vector. Show the change. That's how the physics ledger balances, if you don't see the motion. Yet you claim the jet, the contradiction deepens. Something else is off in the texture of the plume itself. Natural comet jets are messy. They flicker as surface vents light up, rotate in and out of view, and rapidly diffuse. What the stacked frames of 3I/ATLAS hint at is a narrower, more collimated feature, closer to a nozzle than a fog. If ordinary dust can't survive sunward, maybe it isn't ordinary dust. If it's gas alone, where's the broad, bright fan? If it's larger pebbles or metallic fragments, why is the plume so optically efficient? Every attempt to squeeze it back into the comet template creates new pressure points. None of this proves propulsion. Bold claims need disciplined proof. But the correct scientific response to an anti-solar plume is not to shrug, it's to interrogate. What frequencies highlight the jet best? Does its brightness modulate with rotation? Is there an associated non-gravitational term in the orbital fit? Can independent observatories reproduce the geometry? These are the tests that separate illusion from mechanism. So where does that leave us? With an object that won't sit still inside familiar boxes, with a feature that violates our first-order expectations, and with a challenge laid down by Avi Loeb. Stop arguing from labels and start arguing from evidence. If 3I/ATLAS is a comet, it must account for a sunward jet in a solar wind that does not forgive. If it is something else, the data will lead there, step by step, instrument by instrument. For now, remember the image, a sail pointed into a storm and somehow filling with wind. That is the picture 3I/ATLAS has painted across our sky. The anti-tail is not the end of the story, it's the beginning. And as the observations mount, from Hubble's early hint to Spain's 2-meter confirmation, the question that opened this episode remains the only honest one to ask. Is this propulsion, or is there a deeper physics we have not yet named? Stay with the data. It will not flatter our assumptions, but it will tell us what 3I/ATLAS truly is. 3I/ATLAS is not just larger, it is moving markedly faster than its interstellar predecessors. That alone makes it an extreme outlier in both scale and velocity, and in astronomy, outliers refuse to be ignored. When the very first specimen of a class arrives already at the edges of the chart, the natural question is why the debut example is such a record breaker. Then there is the path it chose. Our solar system is essentially a thin disk, with planets circling the sun on the relatively flat ecliptic. Visitors from deep space should, by chance alone, drop in from any angle, above, below, sideways. Yet 3I/ATLAS is threading the ecliptic like a needle, aligned within roughly 5 degrees of the plane, as if intentionally flying formation with the planets. The odds of that alignment by pure chance are tiny. But it gets even stranger. Its arrival time seems almost fine-tuned. Its trajectory brings it for remarkably close flybys of multiple planets, Mars, Venus, and even the gas giant Jupiter. It's like a tourist hopping from one point of interest to another on a grand tour of our solar system. The sheer number of these coincidences is staggering, but perhaps the most damning clue concerns what it appears to be made of. Spectra of the plume revealed something unprecedented: nickel without detectable iron. In natural bodies, nickel and iron are forged together in stellar furnaces and show up as partners in meteorites, asteroids, and comets. Pure nickel with no iron is extraordinarily rare in nature, yet common in engineered alloys on Earth. The ratio of nickel to cyanide also came in orders of magnitude above any known comet in our catalog, including 2I/Borisov, and the surprises kept piling up. Experts expected so massive and active a body to be water-rich, but measurements put water at only 4% by mass. That flew in the face of mainstream predictions and deepened the mystery. It simply refuses to behave like a water-dominated comet. Every fresh data point added another question mark. Polarization measurements registered unusually strong negative polarization, more extreme than any comet on record. And in an eerie echo from the past, the inbound direction sits astonishingly close, within roughly 9 degrees, to the area of sky tied to the famous WOW signal of 1977. The enigmatic radio burst some still sight as a possible hint of extraterrestrial technology. A single anomaly can be dismissed. 2 can be written off as coincidence. Stack 7 or 8 in a row, and you are no longer counting coincidences. You are tracing a pattern. That pattern points away from the easy, natural explanation and toward the possibility that we are witnessing something else entirely. Call it déjà vu from deep space. Before 3IATLAS baffled the community, Oumuamua rewired our expectations. Spotted in 2017, the first known interstellar visitor was small, oddly shaped, cigar-like to some, pancake flat to others, and it tumbled end over end while racing through the inner system. Like 3IATLAS, it declined to play by the rules. As it receded from the sun, it sped up, as if nudged by a force astronomers couldn't see. The default explanation was comet-like outgassing, pockets of volatile ices venting and acting as tiny thrusters. But telescopes saw no dust, no gas, no coma. None of the signatures that shout comet. Acceleration without a visible engine is a hard story to sell. This is where Avi Loeb stepped into center frame. He and collaborators proposed a bold alternative. Perhaps Oumuamua was thin, maybe millimeter scale, and being pushed by sunlight itself. A solar sail. And a solar sail is not geology, it is technology. The reaction was swift and skeptical. Many researchers dismissed the idea as speculative and chased natural models no matter how contrived. A nitrogen iceberg flaked from a Pluto-like world, a fragile dust bunny, a shard of exotic ices. And now, years later, 3IATLAS arrives wearing a new set of riddles. Bigger, faster, eerily well-aligned, touring the planets, brandishing a sunward plume that normal dust physics does not tolerate, flashing nickel without iron, short on water, polarized strangely, and arriving from a sky sector that stirs the memory of the WOW signal. One anomaly makes headlines. A cluster demands explanation. Either we are stacking misunderstandings or we are glimpsing behavior that does not fit the familiar templates. Scientists owe the public more than labels. They owe measurable tests. If the jet is real, its thrust vector should leave fingerprints in the orbit, minute but coherent non-gravitational terms that independent teams can reproduce. If the plume is composed of unusual grains or engineered fragments, laboratory spectra should predict colors and polarization that telescopes can verify. If the alignment and close passes are truly random, quantified probabilities should show it. And if the pattern persists, we must consider the possibility that 3IATLAS is not merely a comet behaving badly. 3IATLAS is not merely a comet behaving badly, but evidence of capabilities we have not yet cataloged. Until then, keep your eyes on the data. 3IATLAS may be the lesson that rewrites our playbook on visitors from afar. Every natural explanation came with its own cracks, demanding an object so exotic that believing in it felt as speculative as Avi Loeb's alternative. The debate over Oumuamua raged, while the object itself was already vanishing, slipping back into interstellar night too quickly for follow-up scrutiny. It left a wake of unanswered questions. Now, 3IATLAS arrives, and it feels like round 2. Another interstellar visitor is displaying behavior that refuses easy classification. The pattern is what most people missed. Though Oumuamua and 3I/ATLAS are wildly different, one small and apparently inert, the other massive and active, they share a core trait. Both present anomalies that undermine the tidy comet narrative. Oumuamua accelerated without a tail. 3I/ATLAS brandishes a formidable plume pointing the wrong way. Each forces us to consider either physics we have not yet systematized or, as Loeb argues, origins that are not purely natural. For Loeb, a second highly anomalous object is not coincidence. It is a data point hinting that such visitors might be far more common than our expectations allow. That raises a chilling, simple question. What if some of these objects are probes? Here is the theory most hesitate to voice. With anomalies mounting, from the sunward jet to the bizarre chemistry to the improbably tuned trajectory, Loeb and a handful of open-minded researchers are being pulled toward an unthinkable possibility. 3I/ATLAS might not be a natural body at all? What if it is a piece of extraterrestrial technology? Not a crude starship, but an autonomous probe sent by a distant civilization to map, sample, and listen, the same way we dispatch Voyagers, Pioneers, and Europa Clipper to explore our neighborhood. Viewed through that lens, the anomalies begin to rhyme. A sunward plume that defies comet physics could be exactly what it looks like. Propulsion. Imagine a plasma engine or another advanced system making subtle course corrections, slowing for observations, or holding position while instruments work. Such a system could produce a focused jet that can push into the solar wind rather than yield to it. A nickel-rich iron pore signature would resemble industrial metallurgy, perhaps cladding, wiring, or structural foils, rather than primordial rock and ice. Low water content would simply confirm that we are not dealing with a snowball, but a machine. An in-plane trajectory with tight planetary flybys would shift from coincidence to intent, a programmed tour of the inner system. Of course, extraordinary claims demand extraordinary evidence. Loeb's case is that the evidence is precisely what we are already seeing. A cascade of anomalies that, when integrated rather than cherry-picked, sketches an artificial profile. He argues the scientific mainstream is suffering a failure of imagination. Reluctant even to examine the extraterrestrial hypothesis, many rush to defend a label, celebrate the presence of a tail, and ignore that, in this case, the tail appears on the creature's forehead. That institutional inertia, Loeb believes, slows progress. History keeps teaching the same hard lesson. New evidence overturns old dogma. If you never entertain extraordinary possibilities, you will never find them. Loeb is not declaring 3I/ATLAS definitively alien. He is saying the data compels us to treat artificial origin as a live hypothesis and to design tests that can refute or confirm it. We should be searching for more objects like this and, when possible, planning an interception mission to meet the next visitor up close. Unfortunately, like Oumuamua, 3IATLAS is a fast passerby, already on its way out. Soon, it will be beyond the reach of our current hardware, leaving us with evocative stacks of pixels and a ledger of questions. That is why Loeb launched the Galileo Project, a program dedicated to systematic searches for extraterrestrial technology. He believes the era of shrugging off anomalies is over, the stakes are too high, and the opportunity is too great. Is it more reasonable to rewrite physics for every inconvenient observation, or to consider that we may not be alone? Tell us where you land in the comments, and subscribe if you want more deep dives into the mysteries unfolding over our heads.